testing YouTube 試音 YouTube 試音 testing OK。好，咁我臨開始再睇一睇剩翻幾位同學喺咪度先，即係未點名嘅幾位。5號梁心怡係未見到嘅，同埋16號陳曙陽，得見到啦。OK， 咁你都仲爭一位，咁我哋都要都開始咧，差唔多都50啦，我哋可以早少少開始都得啦。咁我哋即係可能做少少其他嘢先。梁心怡見到啦 ，OK。好，齊。Okay, then let's all move to YouTube and begin our lesson. Okay, so let's all move to YouTube. So type some message in the chat room of YouTube. For example, hello, good morning, everyone. Type something in the chat room of the YouTube. Hi, hello everyone. Hi, hello. Okay, hello. We will begin with some review of the last quiz, the quiz that I asked you to do before this lesson. It's very good that you have all submitted it, and in fact quite early. In fact, yesterday morning you have already submitted all the work, and I have also briefly see it, and then so we can have a review here, and therefore we change the cover photo to other display first. First of all, let me fix the chat room. The chat room always is stuck, and I always have to refresh it every time. Okay, so a moment please. Okay, seems okay now. Okay, so it's always like that. Every time I go live, and then the chat disappears, and then when I refresh it, it suddenly all appears. Okay, so I changed to the display of the Google form, the quiz form that I asked you to do last time. Okay. So could you see clearly in the screen? Could you see clearly the screen of the in the YouTube? Could you see it well? I try to show some statistics of our results here. Okay. Yes. Thank you. So here are the results. By the way, don't worry about marks. Okay, this is a quiz, and I will not count the marks because it is just to help you consolidate and to help you to refresh what you have already learned in the last lesson. Okay, and therefore at the end we have a quiz, and probably today we will have something similar. Okay, we may have something similar today. And therefore yesterday when someone asked me, will there be quiz today? I say, quiz are sudden, and then it's quite funny. If I say, there will be a sudden quiz tomorrow, that doesn't make sense at all. Okay, so question 1: how many anyones are there in the set? And then out of 26, and then 20 of you have given the correct answer 5. And while maybe I feel say 4, while 6, while for 6 I think it is because this decimal point fake you with the comma. Okay, the decimal point is 3.14. While for 4, I think the misunderstanding will be that you think 3.14 is pi, but they are different. Pi is 3.14 but more, 3.1415, 15629 for example, 926. Okay. Anyway, you can check the 10 scientific figure in the calculator. Okay, so 3.14 and pi are different. Therefore, all these are different things. And then so 5 elements. Question 2 is very good because it is you can refer to the video or your notebook, and that all these set symbols are done very well. For example, the first one, set integer. Okay, very well. And also we can briefly recap it here. 2 is n, natural number, very good. C, complex number, very good. And then 5 is the empty set, also very good. All of you get it correct. And Q for rational number. So for me to remember, Q refers to quotient, therefore it's about divide, therefore rational number. Okay, so Q, rational number, also all correct. And so from now on, try to get used to it. Maybe even at this moment, you still would not clearly distinguish all, but then over the time, try to get yourself more familiar. That means later you don't really need to think. You see out, then you know it's real number. So try to get used to it. And also when we start learning M2, also the one challenge would be to get used to different kind of symbols. For example, today we will also introduce more symbols. Okay, and then the last one is R is real number. Okay, and while question 3 is about which of following is correct. In fact, 1 and 3 are correct. However, not many of you answer 1 and 3 at the same time. Some of you only ask 1 and answer 1, and while some of you answer only 3. But 1 and 3 are both correct. Maybe I can change to the question and see because it doesn't show the figure. So 1 and 3 are correct. 1 is correct because -4/2 is -2, and -2 is an integer. So that is the integer set. While 3 is correct because square root of 7 is a real number. Square root of 7 is not a fraction, but it is a real number because real number include both rational and irrational, and therefore 3 is also correct. 2 is wrong because we have it in the proof. Square root 2 is not rational. While 6 belong to the empty set is wrong because empty set has nothing, so 6 will not belong to it. Also, this is the question 3, and I'll also show you the question here. So next we will go on a bit more. Okay, question 4. Sorry, question 4. This one for the quantifiers. This one we didn't talk about it. We don't have enough time last time, and therefore we didn't talk about it. But still, it is interesting. We don't talk about it, but still many of you can get it correct, and that's surprising. That's quite amazing. And then we can also talk about here the symbol for all, which is the upside down A. It means for all. Okay, the symbol is upside down A. And a little later, I give you some more examples. To show how do we use it. And also, someone also asked me, why do we introduce all these? Why sets? So we will also see how they work. Okay, and while the other one, row 2, there exists. It is left-right inverted E. It's like a capital E, but it is going to the other side. So inverted E, a left-right inverted E. And then that means there exists. There exists means we can find. So later also we will give some examples to show what is the meaning of there exists. We can find. I mean how to use the we can find. Okay. So question 5 is to write a symbol for the inequality. In fact, nearly all of you get it correct. But then just some of you use like the Chinese character close bracket, or the Chinese character of negative, the Chinese character of the open bracket. But these are all correct. In fact, maybe the system does not count marks because there are so many different kinds. The Chinese character, the English character, the full width or half width character. 即係半形、全形嗰啲啦嚇。And then so maybe the system does not count, but I know you are correct. That's fine, okay? Because we are not going to type the answer in exam, and therefore doesn't matter. You know what it means is okay. Okay, but then a few remark. So some of you put this -5 2 with a square bracket for 2. But then be careful that this is not quite correct, because well, the correct answer is -5 with square bracket and 3 with curly bracket. But then note that this 3 with curly bracket is different from 2 with square bracket, because this means it only includes 2, while this one it does not include 3. But we should know there are still more numbers between 2 and 3. Like for example 2.1, 2.2, 2.3, etc. And therefore this answer will include, I highlight it better. This answer will include 2.1, 2.2, 2.3, etc. up to 2.9 or 2.99 or 2.999, etc. But this one only includes up to 2. It does not have 2.1, 2.2, 2.3, and therefore this one does not fit our original inequality. 咁要重複一次啊！呢個大家特別留意咧，就係呢個咧，佢淨係包2啫，但係2.1、2.2、2.3嗰啲唔包㗎。咁如果你想要包到去3，但係啱啱唔包個3咧，咁你要用翻圓括號啦嚇，圓括號呢個咁樣樣。And next, last one is about absolute value. So many of you get this correct, while a few of you maybe overlook the absolute value, because after calculating the -8 plus 5, we have -3. But the absolute value of -3 make it non-negative. Make it non-negative. Then -3 becomes 3. So this is the 3 here. So any questions for this last quiz? Don't be so don't care so much about the marks, because in fact I just find at the very end I forget to add mark for this question 6. Therefore the mark does not really so matter. Okay, so any questions for this last quiz? If no, you can give a no to me, or 0 no. Okay, so just write something for me. Is it okay? Okay. Then I switch it back to my iPad. Then it is my computer display, so I switch it back to my iPad. No, okay. Thank you so much, everyone. Okay, thank you. So I switch it back to here, and then we will go on. Before we really move on to chapter 1, chapter 1 will be one more symbol to introduce to you. But then before that, we open a new page and then write some notes for something we didn't talk about last time, the for all symbol and the there exists symbol. Okay, so the symbol upside down A is means for all, while the symbol with left right inverted E means there exists. There exists means we can find, but in mathematics, especially where in higher mathematics, we usually represent it as there exists. There exists means there is something, there is that thing, and that means we can find it. Okay, so there exists. So how does it work? We can give you some example. So for example, we can say for all let's give an example for all. So for example, for all x, we take it from the set of 0 and 1. Then we have then we have x squared is less than 4. Let's see if we understand this statement. Okay, so it's just that we try to change the symbol into words, then we can understand a little more. We can understand it completely. Okay, so if we try to translate into English, so change it into English, then it will be for all, and then x belong to 0 and 1, that means for all x which is between 0 and 1. Okay, that means I take any x within this range. I take any x in this range. Then you just check is it, if I take x from this range, then you just check is it x change the pen, x squared less than 4. Is it correct? Is it correct for x squared less than 4? Is it correct? Is it x squared must be less than 4 if you take x from within 0 to 1? Is it correct? Yes, right? Yes, because it must be 0 and 1. Therefore, even you take the square, then 0 square will still be 0, while 1 square will still be 1. Okay? Therefore, the square of x will still be less than 4. Now, what about, okay, therefore this is correct. Therefore, it is correct. Now, what about I try to take another one? So this statement is correct. Okay? So what about I take another one? If I take it very similar to this one, but then I change the number a little bit. For all x with in the range of 0, 1. Now this time I use the other bracket. Then x squared less than 1. Then what about this? Is it correct? What about the second one? The second one, is it correct? For all x in the range 0, 1, x squared is less than 1. No, not correct. Not correct. Not correct. Why? But why? Why is it not correct? Why is it not correct? Can you give me an example why it is not correct? Yeah, cos x can be 1. That's exactly. Because x can be 1. Since I am taking an x from this range, any x in this range, then x can be any number between 0 and 1, and we include 0, include 1. Therefore, if just by that chance we take the x to be 1, then 1 squared is 1, but 1 is not less than 1. Therefore, this case it is wrong because x can be 1. Okay, so you can see how we represent statements using the quantifier for all. Okay, how we use for all to represent it. And I think the good thing is that the convenient thing will be that if we represent it here, then we can save a lot of words. Because if we really want to say the words, then it will be for all x. For all x where x is between 0 and 1, then we need to say a lot of words or write a lot of words. But then with symbol, it saves our writings and it saves our description. And also the another obvious good thing is that this we can consider as a mathematical language, and then this mathematical language is not depending on what language you are speaking. So if I am speaking Chinese, I'm speaking English, I'm speaking maybe French, maybe German, maybe Japanese or Korean. Okay, I speak different language, but still the mathematical language is the same. And just like most of us in the world will use Arabic numbers, and then so even different language will still use Arabic numbers, and that's why we have some symbols. Okay, so what will happen when for all is removed? Okay, love. When I okay, for example, yes, that's a good question. When I remove this for all, okay, that means probably that then the statement may not be very complete, because if you just say okay, x is between that means here if you translate it, okay, if there is no for all, if there is no for all, then I use blue for example. Okay, okay, and then so the translation will then be x is between 0 and 1, then x squared is 1. Still, I cannot say this is always true. Okay, I cannot say all the cases this will be true, but because still x can be 1, and therefore I will still not say this is correct. But it will be strange that the sentence seems not correct. Because even you miss the for all, still you seems taking x from this range, and then x squared may still not be less than 1. That's the case. Therefore, we use for all to show that it is every of the x here in the range. Okay, and then on the other hand, so thank you very much. You have whenever you have question, it's good that you can ask it. Next, we try to show we try to show the other one about there exists. Okay, there exists. But then maybe it will be a complete a combination of for all and there exists. Okay, so about there exists. So let's take an example. Okay. There exists x in rational number such that x squared equals to 2. Okay, of course, as a beginning, we do a translation first. We try to translate it into English. So translate means there exists, and then x in Q means a rational number Q, rational number x. Sorry, not Q. Q is the rational number set. There exists a rational number x. St is the short form for such that x squared is 2. Okay, so this is the translation then. Okay, there exists. So the translation match is there exists, and then x in Q is a rational number x. And then such that will be for st, and x squared equals to 2. Then it's a direct equation translation. Okay. So this is the translation. Okay, translate to English and for some understanding. And then my next question is it correct then? Is it correct? So that there exists a rational number x such that x squared equals to 2. That means we can find, again the same similar meaning here would be there exists here means we can find. So is this correct? We can find a rational number x such that x squared equals to 2. So is it correct? Yeah, I see no. Okay, yeah, that is exactly the last quiz. We have already talked about it. The square root of 2 is not rational. Therefore, we cannot find. Okay, so this is wrong because we cannot find. And therefore, if we cannot find, we can use the symbol there does not exist. Okay, so there exists with a stroke to show there does not exist. Yeah, root 2 is an irrational number. That's right. Okay, so this is some more simple. How do we use there exists? Okay, so if in this example we say there exists x in Q such that x squared is 2, this is wrong because we cannot find a rational number. Okay, so and if we want to show we cannot find, then we can say there does not exist. Another one, this one may be a little harder. So let's see if you can understand. Okay, so for all, maybe I don't say. Okay, I try to leave the translation to you because if I say it, then you know the meaning. Okay, so for okay, so this is shown on the screen, but I just write the symbol. I don't say it because I say it, then it's kind of a translation. Therefore, so try to understand by yourself. Okay, understand those symbols, and try to answer: is it correct or not? Okay, is it true or false? I try not to read it. I really want to read it, but I can't. I don't read it because if I read it, then it means the translation. I want to leave the translation to you. So is this correct? Is this sentence correct? Okay, so maybe okay. I see no response. Maybe it is really a little bit too hard. So we can do the translation first, to translate this sentence first. No, okay, no, okay. I get some answer. Okay, that's good. So we translate it. So the first for all x in real, that means real number x. So for all real numbers x, and the next, there exists, that means we can find a real number y such that y is bigger than x. Okay, so Then the second part would be, okay, maybe I highlight it. This is there exists, and therefore this is there exists. And then a wheel number y, such that y is bigger than x. Okay, yeah, I see many of you say f or no here. Okay, so no, maybe y bigger than or equal to x. Okay, so this is the little difference between for all and there exists. For all, if we refer to our last page, it means for all means all. The keyword is all, everything, okay, for all. This upside down A, the turn A, okay, if for all means all. Okay, therefore here, the first part for all, that means for, if I take any real number x here, any real number x, and then the other symbol will be there exists. There exists, to say again here, there exists means we can find, So, maybe I also put it here for easier reference, we can find. And therefore the complete sentence will be for all real number x, we can find another real number y such that y is bigger than x. So with this translation, what do you think then? For all real number x, we can find another real number y such that y is bigger than x. What about this if I translate it in this way? 好啦，最後真係都未聽得明嘅話，中文版啦，OK。對於所有嘅 real number x，我都可以揾到一個 real number y，令到 y 係大過 x 嘅。OK， 對於所有嘅 real number x，我都可以揾到一個 real number y。Such that y bigger than x 咁重點就係我都可以揾到嚇 we can find. The key point is we can find. So we can find, it doesn't have to be you can find a lot. If you can find one, that already means you can find it. Therefore, okay, so for I see some of you change to yes or answer yes now. So now if you say yes, could you give one example? What can such y be? Because the key word here will be we can find. Okay, we can find is the key word here. So how do you find it then? What can this y be? Okay, what can this y be? If I just choose, okay, for any real number x, for all the real number x, that means I choose some any real number x. Can you find another number that is bigger than x? Okay, so if you try answering yes before, could you have an idea then how do you find that bigger than x number? +1係啦，冇錯就係+1啦，+1就已經得啦。OK， therefore the meaning would be OK， 即係意思係呢個即係複雜啲嘅講中文啦，因為要關於嗰個意思嘅問題啊，咁所以中文可能解釋得好啲。係啦，即係話咧，你俾咩嘅 x 我都好啊 ，for all x 啊 for any x you give me 嚇，你俾邊一個都好，所有嘅 x 你俾我都好，我都可以揾到另一個 real number 係大過佢嘅。咁啊，例如係啦，+1就得啦，即係你俾個 x 我咪個 y 咪可以係 x +1咯。個 y 就係 x +1咯，咁咪即係已經 find 到咯。OK，there exists 啦，咁啊即係。所以例如如果你俾個2我，咁我揾個 y 就俾個3你咯。如果你個 x 係俾1萬我，咁我個 y 就俾10001你咯。咁亦都唔一定要+1嘅，你加1萬都得嘅。咁總之就係你可以你俾個咩 x 我都好，我都可以揾到嚇。There exists, we can find. That's the meaning of we can find. And so a short summary of this is so you see we just write a few symbols, but then it can mean a lot. And in fact, it can I mean you can really take time to understand this. Even we just write a few symbols like this. Okay, so here are some introduction to the two symbols for all and there exists. according to my experience in M2, usually we may use the for all more often than there exists. There exists is usually just about finding one, and probably in some proofs you may come across it. But then for raw, therefore that one we may have more chances to use, and I think that for all symbol really save the time with against writing for all, especially in our new chapter 1. Then we will already use it quite a lot. Also, just give this part as a supplementary one with the last lesson. Also, any question up to here about for all and there exists? And then our next part will be really going to chapter 1 and then we begin with the summation notation. Okay, any question up to here? So just understand the meaning. Upside down A is for all, while the inverted E will be there exists, or in other words, we can find. Okay, then we move on to the book chapter 1, chapter 1.1. I just asked this morning. So if you don't have the textbook chapter 1, maybe you could not buy it, or maybe no time, or maybe the COVID-19 is so serious you don't go out and buy or whatever. So if you don't have this textbook chapter 1, you tell me and then I can send you a teacher version copy. However, I'll just send you one chapter because in fact I think you really need to have a textbook. If you haven't, you should buy it. But then right now in this online lesson cases, then I can still send you one chapter. Okay, so this is the first chapter. The chapter name is mathematical induction, and then however today we are not going to talk about it. We're going to prepare for this one. And therefore, the first section will be about summation notation. It's another notation. That means it's another symbol. But I can first briefly talk about what is mathematical induction. It is a method of proof. It is used to prove something. But I just say up to here because at the end of this lesson, I have also posted in the Google Classroom. I have prepared a material, a self-reading material for you. Which is about really how mathematical induction works. And then so you over the weekend, and in fact next time is very far away. Next M2 lesson it is on Wednesday, next Wednesday, and therefore so I would like you over the weekend until before next Wednesday try to read that worksheet. With that self-study worksheet about mathematical induction. It introduces how mathematical induction works, and there is also a video link, and maybe I show you a little later. There's a video link to explain the importance or the key ideas. Okay, and so I would like you to do it with the guidance of the worksheet, and therefore I do not say so much about mathematical induction here. But instead, we prepare for it because this notation will be really helpful. It is the summation notation. So let's begin this part. Summation notation. Very often we will have like formulas for adding up many terms. For example, in fact, one of a very famous calculation, which is maybe in primary school or in lower form also we have is that 1 plus 2 plus 3 plus 4 plus 5 etc. up to, for example, maybe 1000. Then there is a story behind is that a famous mathematician called Gauss, when he is a primary school student, and the teacher give I don't know why the teacher give a long such a difficult question. The teacher give this question when Gauss is very young and primary school, maybe 10 years old, and to calculate this one, and then the teacher thinks Gauss may not be able to do it, but then Gauss finished this one like in 1 minute, and then give the answer instead. So the famous story of Gauss. So whenever we have a very long sum, that means many terms added together. If there are some pattern, we can use a short way to represent it. This short way is called the summation notation. A summation notation means it is about sum, adding things up. And the summation notation used will be as follows. So I try to zoom it up and see it more clearly. Okay, so a summation notation like this may be used. It is composed of different parts. And then on the right hand side of our textbook, it also shows what are the parts. The summation notation with begins with a middle big symbol like this. It is very like E, capital letter E. However, it is a Greek letter. It's a Greek letter and it's called sigma. Sigma. And by the way, in fact, it is a capital letter sigma. And for Greek letter, there is also a big letter and small letter like English. The capital letter sigma is like this. I try to write it again. Okay, a capital letter sigma is like this. You may not need to draw the hook here. It doesn't matter. So if you just draw this one, it's okay. We understand it is the symbol sigma. And it is a capital letter sigma. If you want to also interested in what about the small letter? The small letter sigma is like this. Okay, the capital letter sigma and the small letter sigma. Again, not very beautiful. A small letter sigma. A small letter 應該細啲嘅。Okay, small letter sigma. Capital letter sigma and small letter sigma. Okay, but then what about then how does it work? Maybe why we use sigma? Because it's like S stands for sum, and then sigma is also like S, then S stands for sum. Then we use the Greek letter sigma， 即係好似 S 字頭咁呢個 sigma 字頭咁，所以就叫做就用 sigma 呢個符號啦。Okay, so capital letter sigma, and then this sigma in the middle, on the left hand side, in the middle, and then there are two more parts, R equal to 1, R equal to 4, which means R starts from 1 and then go to 4. R starts from 1 and then go to 4. So when it is from R to 1, R equal to 1 to R equal to 4, that means R will be 1, 2, 3, and 4. We just try to loop over the integers, 1 to 4. Then we consider 1 to 4 will be 1, 2, 3, 4. That is the middle 1.1, 1.2, 1.3 that we don't just care about it. We run through the R from 1 to 4. Run through the R from 1 to 4. So this R equal to 1, R equal to 4. Sometimes we will call this the lower limit. While this will sometimes we will call it the upper limit. 即係下限同上限啦嚇。咁 R 係由1到4，咁下限就係1，上限就係4。Okay, is there some problem? 係咪冇咗畫面啊？係咪冇咗畫面啊？ OK， 好，唔緊要嚇，有可能屋企有少少唔穩定，我要播一播翻，個直播就冇斷嘅，係我仲見到你哋一啲，我見到你哋嘅留言係啦，咁我要播一播翻個 iPad 啊，稍後一下，稍後一下。OK, quit， 跟住再開過。我明。Google Classroom， 唔係 Google Meet 嗰度，熄咗先。Okay, so see if it is back. Is it back? The screen is back, right? Is it okay? Okay, yeah. Okay, so sorry for the technical problem. So sometimes, in fact, it is not so often. I hope it is not so often. My home network is maybe unstable, and then it may be like this. Okay, so back to here. Yeah, back to here. Thank you very much. Thank you. Back to here. The lower limit. Lower limit 即係個下限啊嚇，由1至4咁下限上限嚇 upper limit. And so this shows we are doing adding up. And we add up from 1 to 4. While what are we adding up? Okay, what are we adding up? Then this is the term that we are adding up. So this symbol, okay, if it is in full, then this symbol, it means we are adding up TR. And the other thing to say is that this R match with this R. And here R goes from 1 to 4. Therefore, when we add them up, then this R also goes from 1 to 4 and add up. And therefore, it means that it is change to red. This is T1, T2, T3, T4, and then we add them up. That's the meaning. Okay, that's the meaning of the summation sign. The sigma notation. Okay, this is the meaning. So summation, adding up R from 1 to 4, TR means we have T1 plus T2 plus T3 plus T4. Let's see some real number example that we can do calculation. Okay, let's see some real example to do calculation. Okay, maybe I make up some example. I try to really do this. Okay, so what about if this is a very long sum of example 1 plus 2 plus 3 plus 4 plus 5 up to 1000. Can we use use the sigma notation to write this in a short way? We don't need to write a very long adding up. Is there a sigma notation to do it? Then let's also try this together. Okay, so we can rewrite this one equal to sigma, and then after writing the sigma, write the lower limit and upper limit, and then you can see how we are adding things up. We are adding all the integers up from 1 to 1000. Therefore, the lower limit will be 1, and the upper limit will be 1000. And so this is adding up from 1 to 1000. And what are we adding up? We are adding up R goes from 1 to 1000. Therefore, we are adding up all the R. Okay, so then this will be the short form for this long sum. And again, you see it really helps us with the presentation. It's much shorter way to show this. So is this representation okay? Could you understand this well? 我如果將1加2加3加到1000嘅話咧，我用呢個 summation notation 啦，咁就係 R 由1開始去到1000，咁我將啲 R 加起晒佢，好唔 OK？ 呢個 OK 係咪明白？嗱，呢個係叫做第一個啦。咁我睇多一啲唔同嘅計算，即係可以計到數啊。嗱，書嗰啲好中意俾啲 A 同 B 咁樣樣嘅，咁你冇啲數字睇比較難啲嘅。OK, so I try to give more example. Now what about this? This time we really try to find the value. We evaluate. Okay, we evaluate this. So we try summation R from 5 to 10, and then 3R. Then can we find the value for this one? Can we find the value for this one? So remember, every time when you don't understand the summation symbol very well, if you don't understand the summation symbol very well, then try to write the full form. Try to write the full form if you don't understand, because this short form is for better representation. But if you don't understand the better representation, just write the full form. Okay, yeah, thank you very much. I have the answer. Okay, so I have the answer in the chat room. Alright, so to write in the full form, then that means it is 3R, but R goes from 5 to 10, therefore it is 3, 5. And then R goes from 5 to 10, that means 5, 6, 7, 8, 9, 10. Therefore the other will be 3 times 6, and then 3 times 7, and then 3 times 8, and then 3 times 9, and then 3 times 10. And it is a summation symbol, therefore we add them all up. And then just calculator and get the answer. Okay, so this is how we do this. 不過呢個我未計㗎，我唔 sure 係咪㗎。不過如果你計咗咁 OK 啊，我信你㗎啦。即係凡親你俾啲計數機嗰啲答案我都信你㗎啦。咁我信你嘅135。OK, thank you. So it is like this. And okay, this is the summation notation. That means it is simply a short way for us to represent a long sum. That means if there are many plus 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 and then dot 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 many terms, then we can use this short way to help us to show the results easily. Okay, so this is the situation. While the similar thing is put here, and then the definition 1.1 shows a summation symbol, R from M to N, adding up all the AR, then R from M, M plus 1, M plus 2 up to N, and add up all of them. Okay, so then this is the definition. While something worth mentioning is that when we use this symbol, we say this R match to this R, and then therefore when R runs from M to N, then this AR will also run from AM, AM plus 1, etc. up to AN. Okay, so this R match with this R. But then this symbol does not have to be R, because sometimes R may be already used in the question. And if the R is already used, you cannot use the repeating R again. Therefore, we can also change the symbol, the symbol of R from M to N AR. We can also change it to K. So if we write the second one here, in fact the meaning should be the same as the first one, because it's still K goes from M to N. Therefore, this K match to this K, and so it is still AM, AM plus 1, M plus 2, etc. all the way to AN. And therefore, these two ways to represent should be the same. That means no matter I write R here or I write K here, they should be the same thing. Because when you write the long form, they should still be the same long form. And therefore, this symbol of representation does not depend on what symbol we use here, does not depend on R or does not depend on K. And therefore, we call this R or K here, we call it a dummy variable, which means we use R or we use I or we use J or we use K, they mean the same thing. And therefore, this is we call it a dummy variable. Dummy 就即係嗰啲假人啦，即係有時咧嗰啲撞車測試成日會放個假人喺入邊㗎嘛，咁嗰啲就 dummy。咁 dummy variable 即係係愛嚟頂住個位先嘅啫嚇，愛嚟袋住個位先嘅。咁即係呢度就話俾你知呢個 R 咧係對呢個 R，咁就由 M 至到 N 咁樣樣，咁啊對愛嚟袋住個位先嘅，咁啊就叫 dummy variable。And therefore, we use R, we use I or J, they are all the same thing. However, the M and N shows the range, then they are important. We cannot change M and N to others. If we change to others, then the sum will be different. But R, I, and J, they are the dummy variable, which means we can replace it with anything. Okay, then some concept check here. So find the value. We have the answer, therefore we just go through it very quickly. Summation of M from 1 to 4, and then add up all the Bm. That means we want to add up B1, B2, B3, B4. And the B1, B2, B3, B4 are all given here. Therefore, only up to 4, therefore we don't need this 5 for the first part. So adding them up all, and we have 2. I only have the teacher version, therefore the answer is shown here. But then it doesn't matter, because even in your student book version, you also have the answer at the back. Part B, if we are adding up M from 3 to 5, then we add up 3 to 5, add them up, then we have 3, 2, and 4 add up, and we have the 9. Next, if we are to express this in a summation notation, then we just see what the pattern of the adding up. It is a 5 square, 6 square, 7 square, up to 20 square. Then all these are number square. Therefore, we can write the summation, and it goes from 5 to 20. Therefore, R equal to 5 to 20. And what are we adding up? Then we are adding up the square of those R's. Therefore, adding up the R squares. Okay, so that's for an introduction of the summation notation. And I see the time now is 35 already. Also, is there any question for this introduction with the summation notation? Any questions to you? So this is the introduction. We will see more properties. That means, okay, we have a new symbol, a new notation to help us represent something. Would there be very fast property that we can use. Because if we have some property with the summation sign, then we can work with sums easier, more convenient. Therefore, next time, before we begin with the mathematical induction, we will see some more properties of the summation notation. And then so we will do it next time. Any questions up to now? Any questions? Any questions? Okay, so I know it is a little bit hurry. Okay, if you have other questions later on, then you can feel free to ask me later, maybe in WhatsApp or whatever. Okay, and before we leave, there will be a short quiz. I will also send you the link in the WhatsApp. And this one is about the translation with different symbols for all or there exists. So you also fill the quiz later before the next lesson. There are a few days. Okay, don't worry. Okay, I'll send you the link in WhatsApp, and also in WhatsApp and maybe not here because you need to leave now. Okay, so that's it today, and then see you later. In fact, it's lesson 4. Lesson 4 is lesson 3. Lesson 3 is mathematics. Then we will see you again later. Okay, so goodbye. See you.